Start. Okay, cool. Hello everyone. So my name is Numan and he's Dumitru. So we'll be talking about using OVN Interconnect to scale Kubernetes deployments for OVN. Okay. So let me just brief a little bit about what OVN Kubernetes is. It's a CNI plugin. It's a Kubernetes CNI plugin which uses OVN and OVS, and it's an OVN community project. So this slide, what you see here is a present architecture, how OVN Kubernetes is deployed with Kubernetes, with OCP or any other Kubernetes deployment. This is how generally it is deployed. You will see on the green, there are master nodes or the central nodes where OVN central components are deployed. Basically, you have ovn-northd and the database servers running. The OVN database servers are mostly deployed as a Raft cluster. And OVN Kubernetes has two services running mainly. One is called OVN Kubernetes Master. It runs on the master nodes. And OVN Kubernetes node and ovn-controller runs on each node, both worker node and the master node. So generally, master nodes run your API server as well, and they will be either deployed as 3 or 5 nodes. Okay, so what's the problem which we are trying to address here? So in the present case, like from our test, what we have noticed is that OVN southbound database becomes a bit of bottleneck as we scale. Like if your deployment has more nodes, maybe 100, 200, 300, as it goes up, it becomes a little bit of bottleneck as the database size increases. And also, there can be some Raft issues where there is a leader election, frequent leadership changes happening. Yeah, we do have a lot of improvements now with OVSDB server. And also OVSDB server is single threaded, and as you have more OVN controllers connecting to it, it could have an impact on that. And also ovn-northd does take CPU since it has to process all the changes whenever it wakes up. So as your scale increases, the complexity of it also increases, and it has to process more logical resources to convert the logical flows. Okay, so in this slide, I want to talk a little bit about what is OVN Interconnect. It's a feature in OVN. It's part of OVN project, and it is used to interconnect multiple OVN deployments, independent OVN deployments. It has a global interconnect databases deployed, which is accessible to all your clusters. And there is an OVN IC service which runs on each of the OVN deployment. And that OVN IC talks to its own local OVN database and also to the global IC database. And it creates some transit switches so that the traffic can go from one deployment to the other. Okay, why do we want to use OVN Interconnect in the case of OVN Kubernetes is basically to address our scale requirements. And also we would like to avoid the worker nodes talking to the central OVN database servers. We basically want OVN worker nodes only talk to the API server and avoid talking using the 6641 or 42 ports. So this is what we thought we could use OVN IC in this kind of new architecture where each worker node or each Kubernetes node runs a complete OVN stack, also including the OVN Kubernetes services, which is OVN Kubernetes master and node, and we would use the interconnect feature to connect all those OVN deployments. So all your east-west traffic would kind of be handled as an interconnect, like the traffic going from one local OVN deployment to the other one. But it's actually one global Kubernetes deployment. I mean, basically, we want to know if this solves our scale requirements. Like, would it help? Like, since we only have one each node acting as a deployment, we don't have Raft. the local OVN components can talk via Unix sockets. So, and the database size is smaller, and ovn-northd has to process less flows, and it has to do less work. So, will that help? Is the question. So, let's get into a little bit of internals of OVNIC, which Dumitru will take over.
Yeah. So let's talk a bit about how we actually want to implement this in OVN Kubernetes. Numan said that OVNIC is a native OVN service, but because we don't want to expose even more services the nodes have to connect to, we're actually going to implement this in OVN Kubernetes itself. So we're going to skip using the OVNIC daemon, and we're going to use what we call zones in OVN Kubernetes to implement the interconnect functionality. What's a zone? A zone is an independent OVN deployment. One Kubernetes deployment can have, a Kubernetes cluster can have one or multiple zones. A zone can have one or more nodes, but a node must be at least at most in a single zone. Each zone will run its own OVN Kube master or masters if they run in HA. So they will have, Numan said, northd running, northbound and southbound databases. This is how it looks. Here we show 4 different zones with different combinations. In the first one, we have 4 nodes in the zone. In zone foo, in zone bar, we have 2 nodes. In the other 2, we have 1 node each. The thing that's in common there is that they all run OVN Kube master. So they all run the central components of OVN because each of the zone is an OVN deployment. Let's look a bit at the logical topology in OVN Kubernetes. This is what we have today. We have a distributed cluster router and a distributed joint switch, and these logically connect the nodes in the cluster. We have a single set of databases, northbound and southbound, and ovn-northd. And then per node, we have a node switch, a node logical switch, a node external switch, and a node gateway router. We want to change it to something that looks like this. In every AZ, in every zone, we basically have same deployment, the same logical topology as we had in the centralized OVN Kubernetes cluster. And we connect these together via a logical transit switch. So the OVN cluster routers are not distributed anymore. The joint switch is not distributed anymore. The only thing that's distributed is the transit switch. What does this mean for creating resources? So let's look at creating a pod. In the centralized current case, what happens is first OVN Kube master will create the node logical switch port in the northbound database. Also will create the V's, plug it to OVS on the node where the pod will run. northd creates the southbound port binding, and OVN-controller merges everything together and claims the port and installs the open flows that are required to do the network. In the IC case, it's basically exactly the same thing, except the first stage happens on the northbound database. So OVN Kube master will write to the northbound database running on the node where the pod will also run. Everything else is the same as in the centralized case. What about services? For services, OVN Kube master creates OVN load balancers and applies them on the node switches, and on all node switches in the cluster, and also on the node gateway routers. These get translated by OVN controller on every node to open flows to implement the load balancing. In the IC case, we have to do exactly the same thing. The only difference here is that the load balancers will have to be created on all nodes. So all OVN Cube nodes in all zones, all OVN Cube masters in all zones will have to create the load balancers in the northbound database. For network policy, that's implemented in OVN Cube by using ACLs that refer to the ports, the network policies, the pods that the network policies select via a port group and an adder set. And the ACLs get applied on the node switches. In the IC case, what we have to do is split the port groups and create independent port groups in every zone, including only the pods that are local to the zone, and everything else stays the same. We apply the same ACL on the switches of both zones. So what I was basically trying to say is that there's not much change in OVN Cube. All we need to do is ensure that we can get traffic from one zone to the other. And then the features, the way OVN Cube implements the features is almost the same as it does today. And to get the traffic, we need to add a few more routes. On each OVN cluster router, we need to add the routes for east-west traffic, north-south traffic that has to either go out via a remote node or via the local node. There is a special case, and that's multicast. For that, we actually had to add the support for multicast on transit switches in Core OVN. But that's merged, available, released already. So what we do is we enable IGMP snooping on the node switches. We enable IGMP relay on the cluster routers, and also IGMP snooping on the transit switch. That means whenever pod registers for IP multicast, it will send an IGMP report that's going to be learned by all relevant parts of the network. Whenever a source starts sending IP multicast, that will be efficiently delivered only to the pods that register for it. Yeah. How do we implement all this? I said we don't have an OVN IC native daemon. Instead, OVN Cube Master will take over the work that OVN IC was doing in Core OVN. So it will create the remote chassis in the southbound database. It will also create a transit switch, the transit switch ports, both for the local and remote nodes, and connect those to the OVN cluster routers. It will also add routes to implement the interconnect feature. So it will add the routes I showed on the OVN cluster router. We do need one special custom module service. That's the cluster manager. This is a centralized service that runs on the master nodes, and its main role is to allocate a unique ID for every node. And that unique ID is used to generate a unique subnet for the transit switch, for egress IP, and so on. It doesn't really need to connect to any OVN database. It will store that unique information in every node's annotation.
So let's just see some of the testing which we did with comparing both the upstream OVN Cube upstream and with this IC, how it looks like. So what we did was we have a lab of 48 physical machines with the configuration over there, and we deployed Kubernetes using kind, but with a little bit of modified kind called OVN kind heater, which kind of interconnects those physical nodes. So out of those 48, so one machine we use it as like a master role, and on that we bring up the first 3 kind nodes which act as master nodes, where your API server would come up. And the remaining on the remaining 47 machines, we deploy 188 kind nodes. So roughly on each machine, 4 nodes are simulated. We use Cubeburner. Cubeburner is an upstream project which is used to test, do some scale testing of your Kubernetes deployment. and it has a test called kubelet density light, which we run. It basically creates just pods on each node, like 250 pods per node, and at 20 or 25 requests per second. And yeah, it just basically creates those pods and measures how much time it takes for each pod to be ready. And so that's it. And then we measure what is the memory and the CPU utilization of each OVN Kubernetes pod using Kubernetes. So just to recap between the differences, like in the case of upstream deployment, we have OVN Kube master and the ovn-northd and the database running only on the first 3 master nodes, and on the remaining nodes we only have OVN Kube node and OVN controller. But whereas in the case of interconnect, we have one daemon set called OVN Kube local, which runs on each node, so because we want to run whole OVN stack in each node. Yeah, so this is how what the Cubeburner test looks like. You could see that there's a decent amount of improvement in the average time it takes to create those pods and for them to become ready. Yeah, and also the P99 and P50. It's better with OVNIC. So, and yeah, I think the main thing we want to highlight here is the memory and the CPU utilization. Right. So this is in the case, this slide, what you're seeing is in the case of the OVN Kubernetes upstream deployment. And on the master nodes, you would see that ovn-northd is taking around 1.6 core and OVN Kube master around 0.6. And the memory also is there, like 824 ovn-northd and around 1 GB of OVN Kube master. So that's only on the 3 nodes. Yeah, and this is the DB information which you can see, northbound and southbound, and yeah, memory and the CPU utilization. The one thing to note is the memory usage of SB server, which we probably can compare later. Yeah, and this is on each node, the worker node, where the OVN Kube node runs, where OVN Kube node service and OVN controller. So the memory utilization of OVN controller, you can see it's around a little higher. Yeah, but otherwise the memory, yeah, the CPU is fine. So, but this is like, yeah, this is for the case of IC deployment, interconnect deployment, where on each node the OVN Kube local pod, which consists of the whole OVN plus OVN Kubernetes stack, it takes around roughly around 2 cores and a memory of 800 MB. Yeah, so this just breaks it down on each node, the NB and SB CPU utilization. Yeah, so this is the ovn-northd and OVN controller CPU utilization. Northd again is taking this little lesser than the upstream OVN Kubernetes, master deployment. And so this one is, yeah, the OVN Kube local master. This is the same as OVN Kube master, which runs on the upstream deployment. Yeah, but on each node. Yeah, so this, I think, yeah, so this is interesting. You can see that CPU and the memory utilization. On the left, you would see the CPU utilization of each of the services. You can see OVN Kube master and node is almost the same. On the left side, that's the CPU utilization. But you would see a very good reduction in the case of IC for OVN-northd. Yeah, OVN-northd, and yeah, it's less. But for southbound OVSDB server, in the case of interconnect, there is a slightly higher utilization of OVSDB server. We have figured out the reason. It's basically OVN-northd needs to use mutate when it adds the address set. So basically, whenever a pod is created, its address is added to the namespace address set. In the case of interconnect, when a pod is created on a remote node, another node, it still needs to add the address of that, but it kind of doesn't. It's not that optimized now. So if we do that, the reduction would come. I mean, you would see an improvement there. So on the right side is what you see, the memory utilization. Yeah, you can see the difference there. the main thing is that the OVN deployment has, just the OVN services has a better memory usage for the case of interconnect, and also even for the case of OVN Cube Master. Yeah, the only thing which I want to highlight is it's per node, whereas only for OVN Cube upstream, it's only for the 3 master nodes versus 1 for every node. So this is the database size. Again, it has the southbound DB has greatly reduced because we just store only the local node in, data. So you don't have to have logical ports of other nodes. So that's why the size of the database comes down quite drastically, significantly. Yeah, so this is what you could summarize, that the CPU utilization of, if you just take the worker nodes, right? So definitely there is an increase of the CPU core for the case of OVN Cube Local, because, yeah, which I think can be optimized further, and we can definitely get it down. We can improve OVN Cube Master to take less CPU. I think we can improve there. Yeah, but memory-wise, I don't see much of a difference. Is this little more, but overall, if you see, I think that it helps in the scaling with a little cost on the CPU and memory per node. So these are some of the conclusions. Like if you see some of the cons of this approach is like, yeah, the database is replicated on each node, even though it's smaller size. There's some duplication of the data. And as I mentioned, there is an increase of CPU and memory usage on each worker node when you compare to the other deployment. And the debugging could become a bit difficult because now OVN trace would not work. Okay, I think we are running out of time. And we also tried to switch per node topology. Right now, OVN Kubernetes is like for every node there is a logical switch. Now we are tied to that topology, and you cannot probably. If you want to have a different implementation, it might be hard. Some of the pros is like, yeah, there is a decentralized architecture. We don't have to use Raft now. There is an increased end-to-end latency, and yeah, and the ovn-northd resources has come down a bit. And that's it we have, I guess. Yeah, any questions?
We're opening up for questions. We have fun back there. I'm going to steal your microphone again. I'm sorry.
So Numan, with this, do we still have the concept of a OVN Cube Master anymore?
Yes, but that master would be running on each node. On each zone, actually. Yeah.
Zone.
Yeah.
All right. The second question, I think I know the answer, just to confirm with, if you were to keep things the way they are today and create one big zone, right? Is there any disadvantage in it? Do you lose anything by having this with one zone?
Nothing. I don't think there is disadvantage. It would be the same as
What
the
we have
previous.
today, right?
Yeah.
I guess I'm using that as a pretest for folks who are opposed to it. They shouldn't, because they can just still have one zone and not lose anything.
Yes, that's what. Yeah. You want to add something?
The thing is, the tests already passed using a single zone, and upstream OVN Kubernetes tests work fine. So it's not breaking anything.
One last question. Oh, Aaron has one.
Well, we has three.
Okay, I'll do my last one, which is, now that you are using Unix sockets instead of regular sockets, do you see any advantage? I guess you don't need probing. Do you see any improvements or any advantage? When you have all these things co-located in one node, you no longer have to use TCP, right? Like you said, you can just use Unix sockets.
If you want to go, one node per zone, but if you want to have multiple nodes per zone, then you still need to use SSL or TCP.
Of course, makes sense.
Hi, I have a question from the chat from Aline, and he says, thank you for the presentation, Dumitru and Numan. A few questions. Is it still possible to have a single zone? Which versions of OVS OVN were used for testing? And are there any known deployments of interconnect in production?
Okay, so yes, we can have a global zone, which will be the same. And we used, I'm sorry, we apologize, we did not put that information. We used the latest OVS master and OVN main and OVN Kubernetes for our testing. The third question, can you repeat or do you know?
Yeah, if there are any known OVNIC deployments, yes, I think there are people using it in production. I saw patches coming in from, I forgot the name of the company, but yes, it is used in production for sure, OVNIC. Not OVN Kubernetes with IC, but OVNIC itself.
Thanks.
We have another question from the back of the room. Running.
Just to clarify what Flavio was asking and what Aline was asking about the single zone, I think it's not really the same as having the current deployment, because you are not deploying databases in Raft mode, it's in clustered mode, so you're losing high availability if you're deploying single zone setup. Is it correct?
No.
Yeah. Or can you deploy single zone with Raft inside of it?
I think we were a bit unclear. If you can choose to still use Raft. So you can, if you have a zone with multiple nodes in it, yes, then you should probably enable HA, so you should deploy your databases in Raft in that case. And then it's equivalent to what you have today if you use a single zone.
Okay, so you are choosing several nodes from the zone to be masters?
To run the central components for that zone, yes.
Okay, makes sense. Thanks.
All right, thank you so much. Do we have one more virtual question?
So this is a question from Brendan Doyle, who asks, what about high availability? Are the north-south DBs on each node independent? If not, how are they synchronized? If not, then we lose the HA of the Raft cluster.
As I mentioned, if you assume each node becomes a zone, then it's an independent OVN deployment, so it doesn't know about the other zones, other deployments. So you don't need HA for that, and and we interconnect using the transit switch, which is replicated on each node, right? So you don't need to duplicate or have HA for that. You want to add something?
No, I guess the reply to yes question is for the second part.
Oh, yeah.
Just a thought. I guess as soon as you have a zone with more than one node in it, you need to deploy databases in Raft mode to have high availability inside the zone.
Correct. Yes, sir.
Okay.
I mean, so that we don't disrupt the existing deployments who don't want to use this interconnect functionality, right? In that case, for them, it just becomes one zone default or a global zone. They can just deploy with HA and everything the normal way.
I'm saying that if you have a zone, if every node is its own zone, then losing a zone means losing one node, and you don't need high availability for that. But if your zone contains more than one node, then you may lose one node and lose the entire zone if you have only one master, one database set in it. So as soon as you have more than one node in a single zone, you have to deploy databases as a cluster.
Correct. Yes, that can be done.
Okay, thanks.
All right, wonderful questions. Oh my God. Do we have any more virtual in person? Going once, going twice? All right, I guess we're gonna go move on to the next presentation.